Hello, F Sharp. I hope you're doing well. So I'm back with another video where I look at an interesting problem and investigate several different approaches I could take to it with F Sharp. Now, again, I'm very concerned about performance and speed. Most of my time I spend writing bespoke simulations for manufacturing facilities and supply chains. So this is not a talk on domain-driven design. If that's what you're looking for, you should go somewhere else. But what it is an investigation of different legitimate approaches that you could take to attacking this problem in F Sharp and kind of weighing the pros and cons of those. And the reason I'm doing that is I wish there was more of this kind of content for me as I was as a beginning developer and as I was learning and growing. So hopefully I can provide you some of the knowledge and wisdom that I've gathered, although I am still very early in my journey as a developer. I'm trying to learn more every day. So hopefully you find this helpful and you have thoughts or feedback. Please feel free to leave a comment. I am actively trying to grow as a developer, so I love getting that feedback. So let's talk about the problem that we have right here. So in the simulation that I'm writing right now, I have jobs and I have machines, and I need to keep track of which jobs can be assigned to which machines. And as the simulation moves forward, jobs get assigned, and then they're no longer available to be assigned to other machines. And so maintaining this set of possible assignments right now is actually the bottleneck for the simulation, because I have to know, like, okay, what can or can I not assign, what's available or not available. So this is a really critical piece of the code. So I needed to find a way to quickly update what is and is not available. And so I thought, hey, naturally, okay, I have sets of things I need to remove from it. I need to add to it. Oh, and there's another important piece. It needs to be immutable. And the reason for that is that this is, I have to be a little careful. The algorithm that this is embedded in is keeping track of states. And so I can't just use like a hash set and, you know, just quickly update things and using mutation. I have to actually have an immutable way of doing this so I can keep track of previous state, next state, and seeing what's changed. And so I believe what you're seeing on the screen right now is I kind of listed out some different approaches I thought of taking. And those are, I could use a default tuple, I could use a struct tuple, I could use the default record type in F Sharp, and I'm saying that's a ref type, and I'm going to keep pointing that out because I think it's an important thing for developers to remember. There's a struct record. I also tried out using an int64 with a unit of measure, so a little interesting thing there. Then also did a struct wrapper around an int64 and then a bit array. So let's go to the code so you can see what this looks like. So here I am. And this is, and if you want to follow along and actually look at the code, the link is down in the description. So feel free to follow along or just watch what's on my screen. But here we are. We have, and if you spent more than 10 minutes with me and I'm talking about F Sharp, you're going to know I'm a real fan of units of measure. And the reason for that is, for me, it's essentially a zero cost abstraction that gives me the raw performance of primitives, but additional safeties and description around what they're meant to represent. So something that I do all the time is I'm annotating floats and ints and int64s with the units of what they're meant to represent. And again, it's all for going fast. So I defined some units of measure here. I have job ID and I have machine ID. And an assignment is just the product of those two things. So it's like, hey, it's a combination of the job ID and the machine ID. And the fact that it's a combination is going to be important later. So if for the approach one, I was like, okay, I'm just going to use a normal tuple. You can see what that looks like here. Default tuple. It's like, okay, I have an int that I've annotated with the job ID unit of measure, and I have another int and I have a machine, and I'm annotating that with machine ID. So that tuple represents an assignment. F Sharp also has a struct version of tuples, and this can be really advantageous if you're using tuples a lot. If you're not careful, it can cause, you can create a lot of objects and cause there to be additional garbage collection. So something to just be aware of if you're doing some profiling. So measure first, don't assume. Please don't assume. Measure first. And if you're seeing like, wow, I got a lot of tuple allocations going on, and a struct tuple may be something to try. It might be able to help you. I then have what I call the third approach. So this is a F-sharp record, a plain F-sharp record, and I'm just prepinning this with a ref just to, again, kind of denote the difference between a normal F-sharp record, which is a reference type, and the next one, which is a struct record. So you can annotate structs in F-sharp, sorry, you can annotate records with the struct attribute. And that tells the F-sharp compiler how you want this thing laid out in memory. And so in theory, by using the struct attribute, it's now a value and not a reference. And so how it gets passed around and how it gets used is different. It's not a cheat code for going fast. It is not something to do by default. So if you ever have a debate, go with the default reference type of record in F-sharp. And only when the situation, only after you've measured and validated that using a struct is going to make it faster, only then should you do that. The fifth approach is where things get a little bizarre and interesting. And remember, this is not me saying this is what you should do. This is me just investigating a lot of approaches and showing you what the implications are. Now, this approach is not original to me. This I got from an excellent talk by, and I apologize ahead of time if I mispronounced, Jeremy Chassang. Oh, that is so badly pronounced. I know it's French. I should know how to pronounce that better, but he's an amazing F-sharp developer. You should definitely be following him. He's an architect at D-Edge, and his talks are fantastic. So be sure to check it out. So I got this idea from him, and what we're doing here, and I can go ahead and zoom in again just to make sure this is really clear. I'm not going to close this for you. You don't need to see it. So what we're doing here is you give me an int that's been annotated with job ID. You give me another int, which is the machine ID, and that is an int annotated with machine ID. And what I'm going to do is I'm going to take that job ID, sorry, the highlighting is kind of getting in the way, and I wish I could point. I need to figure out how to do that. But here on this line, what's happening is job ID is getting turned into an int64, and then I'm shifting those bits 32 to the left. Now remember, these are two ints, and I'm basically going to compact them into a single int64. So I take job ID, turn it into an int64, shift it left 32 bits, and I then OR that with the machine ID. So what, at the end of the day, I'm going to get an int64. I've annotated with assignment, which is what this function does. It says like, hey, take that integer int64 and put this unit of measure on it. That's what this line is doing. The top 32 bits are the job ID, and the bottom 32 bits are the machine ID. Why on earth would you do something like this? That's a great question. Man, how to say this? So the CLR is very aware of raw primitives, int, int64, bulls, those types of things. And so there's optimizations in there, and when it sees that, it has additional things it can do to optimize your code. When it sees this, it's like, oh, before, if I had job ID as an int, machine ID as an int, and I needed to put that into the CPU to do some work with, that would be two different registers. But if it's an int64, if I compact them together, I can actually pass that value to another function by putting it just in a register. And so it doesn't have to like go in and out of the register. So there is potential speed up here. The other nice advantage to this is that in the set, like the F-sharp set, and we're going to be comparing values like, hey, do you see this assignment? Instead of needing to compare two different values, comparing the int32, which is the job ID, and the int32, which is the machine ID. It's comparing a single value. And that single value is in a single register instead of being spread across 2 registers. So that is why you might want to do something bizarre like this. Again, do not jump here, but it's an interesting thing to try to say like, hey, does this even matter? Does it do anything? We'll find out. This is the same idea, but now we are wrapping that integer int64 in a struct, and we're providing some members for extracting the job ID and the machine ID. Now, in theory here, I could add some functions for taking an int64 and then getting the job ID back out and the machine ID back out. I'm not, because I don't need to for these tests, but that would be how I make this approach equivalent to this approach. But this is a more normal way of doing this. I'm hiding the representation. I'm forcing you to use these members in order to extract those values out. So again, just another approach, and this is meant as an investigation of kind of all the edge cases of the F# compiler and the CLR. Like, what is even in here, and how does stuff work? And then there's the last approach, which is, instead of tracking assignments as individual values, what we do is we create a bit array, one long bit array. And the reason we're doing this is because in this domain, the number of jobs is typically in the hundreds, usually 100. And the number of machines is also typically very small, 10. 100 would be huge. And so if you think about the number of bits you would need to track for any given machine in any given job, so like if you have 10 machines and 100 jobs, that's only 1,000 bits. And then that's really small. So what this does is it creates a bit array, and every bit represents a combination of the job and the machine. And a 1 says, yes, this combination is available. And a 0 says, no, this combination is not available. And so what this does is it provides some convenience functions for wrapping that bit array and then indexing into it. And so it has a private constructor that you're not supposed to use. But what you do is you say, hey, I need to track this many jobs. So job count. I need to track this many machines. It creates a bit array whose length is the product of job count and machine count, and then creates it for you. So it's like, okay, I got 10 jobs and I have 10 machines, and now I need 100 bits in order to track this. And so to get, hey, is this job and this machine, is that combination, what is the value of that bit? Is that true? Is it not true? Is that assignment available or not? What you do is you give it the job ID and the machine ID, and then you do some math to index into what the appropriate bit is. Hey, F#, it's Matthew from the editing room. When I was reviewing this, I realized that my implementation of this method was incorrect. I had the calculation of the index, but I wasn't actually looking up the value. So my apologies for that. If you're following along with the code in the repo, that is correct. But here in the video, you're seeing that it's not quite right. So I want to let you know I do acknowledge that. My apologies, but this is the correct version. I did not have time to re-record everything, so I'm just putting this little correction in here. Thank you very much. My apologies. Get you next time. I realize that this approach is a little silly and absurd, but again, it's like, how fast do you need to go? I'm assuming you have already answered that question. I'm just telling you, like, hey, how insane can we possibly go with this? And if you want to set a single value, it's the same kind of thing. You give me the job ID, the machine ID, and the value you want me to set it to. And again, this thing is still immutable. So this data structure, so that might start setting off some alarm bells for you. So the first thing it has to do, it has to copy the existing values, calculates the index of what it is that you're wanting to set the value of, sets the value, and returns a new bit array tracker for you. Again, because in this domain, for this problem, this immutability is really important. And what you computer science people who actually have a degree in computer science might be shouting at this point, like, oh my gosh, it's going to be so inefficient. I know it's inefficient, but think about the domain. We don't have that many machines. We don't have that many jobs. So will this scale? No, but may it be good enough for what we do for this? That's why we do benchmarks. And also, I create a method for setting a bunch at the same time, because the way the simulation works, when I assign a job to a machine, all the other assignments for that job and for that machine need to be invalidated. They need to be like, none of those are available anymore. So I am always doing bulk updates. So this is here just to show you how to do it for a single one. But typically what you would be doing is a bulk update. So again, I copy the values, and for each combination, I'm calculating the index and I'm setting the value to whatever it is I want to set it to, and then I'm returning the new bit tracker. That's it. So these are all the different approaches that I looked at. And if you look at the benchmarks, there's nothing really exciting going on here. I create a random number generator, and I ran a bunch of different scenarios, and I'll show you those results. And I looked at kind of several different scenarios, changing the number of jobs, the number of machines. But what you see here is there's nothing too exciting going on here. Here I create a set. I'm creating the initial set that I want to update, and I have to do that for all the different approaches that I'm taking here. So I have the tuple value approach, I have the struct values, the int64 values, the ref assignment. Yeah, you see what's going on here. I'm just creating a bunch of different sets using the different types inside of the set. And then I have the bit array tracker approach, and it has a slightly different API, so I have to do something a little bit different for it. But then what I do is I create, hey, here's all the values that when I want to add all of these to the set. I want to add all these assignments. So here I generate the tuple add values, the struct tuple add values, N64, blah, 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 it repeats. And the important thing is it's all the same values for every scenario. So no matter the approach, it's adding the same values to the set, and it's going to be removing the same values from the set, which is why I create, like example here, hey, here are the tuple remove values, and then to create the struct tuple remove values, I take those and then I transform it to the shape that I need to do the test. And down here, I then have, okay, here's my tuple add test, my struct tuple add, N64 add, on and on and on and on. So, and then I have all the tests for the remove. So nothing terribly exciting there, but now let's look at the results. And I think that's where stuff gets really interesting. So scenario one, I have 10 machines, 100 jobs, and I'm needing to remove or add 10 assignments from the set. And so what we see here is that the tuple add and the struct tuple add essentially the same performance. That int64 approach, where we took the two different int32s and compacted them into an int64, that's significantly faster. We also see that the different record approaches are not as fast as the N64, which is to be expected. And this is why compacting it into an N64 is advantageous. You have fewer things to compare versus I have two fields that I need to repair. So records, faster than tuples, compacted is even faster. And we see that one approach I took where I took a struct that was wrapping the N64, there's nothing terribly exciting there. It's about the same as a record. What is maybe surprising, maybe not, is that the bit array tracker approach is way faster, way faster. And so these are all the add methods, and then here are the remove methods, and we're seeing essentially the same trend in performance. Again, tuples, the tuple approach, the record approach, and then that compacted N64 approach, and then the bit array tracker. And if we go down to the scenario 2, I still only have 10 machines, but now I have 1,000 jobs, so potentially a whole lot more, and I'm still removing and adding 10. And the reason for 10 is because that's the domain I'm working on. This is the number of elements that I'm typically updating at a single time. Again, we're actually seeing very similar trends, a little slower, but not significantly. Bit array tracker is about twice as slow. It went from 49 nanoseconds up to 87 nanoseconds. And this is the fact that, like, yeah, because each time it has to copy that entire bit array. Now, the bit array is very small, but it still has to copy the entire thing. Again, similar results. Again, speed of the bit array approach for remove is also twice as slow. And then for this last scenario, so this would be like beyond, this is the absolute edge of anything that I would have to simulate for this particular problem that I'm working on. 100 machines, 1,000 jobs, adding or removing 10. Again, a little bit slower, but the trend stays. This is now, again, getting significantly slower, and it's an order of magnitude slower because the size of the data has gone up an order of magnitude. So it has to copy an order of magnitude more data. But what we're still seeing is that it's still much faster. Now, takeaway. For what I am working on, because of the demands, using this bit array tracker approach is what I'm going to use. But I will fully acknowledge this thing does not scale. I am aware of the bounds of the simulation that I am working on. And so I know, like, hey, this is still way faster even at like the largest sizes that I'm dealing with. Okay, that's what I'll use. If I was writing something generic, I would not use this approach because as this gets larger, this thing is going to die. It's not going to scale. There are things that you can do, though, to get that speed back, and that is kind of breaking up that key space and then only updating like certain pieces of it. At that point, you're doing something more, not like kind of like a B tree, but not really. Someone's probably going to throw mud at me for that one, but it's the idea of like you break up that key space into chunks, and that way you only have to update a certain subset of it, and so you're not having to copy as much data. So there's clever things that you can do to keep that I would do if I was putting it into code where I did not know the limitations of the scaling. But I thought this was really interesting to look at, and hopefully you found it helpful, just kind of exploring the implications of different ways of structuring and representing the same data in F#. The takeaway, if I was doing just generic F#, sets with just the normal record are great. That is a great default. And what you're seeing is the performance difference between the other kind of normal-ish approaches is not that big. I mean, it's faster than tuples, which is great, and it's more descriptive. It's more indicative of the domain and what stuff is meant to represent, which is fantastic. So that's the default I actually started with because it was like the obvious thing. But then I wanted to kind of explore, like, be curious to kind of see all the different ways we could do this and what the implications are. So my recommendation for someone who's just learning F# and like, hey, what should I do? Normal records. Normal records will take care of you and they will take you far. So don't worry about it. Only when you know that you have a particular hot code path that is the most critical thing, that is the bottleneck, should you ever consider something like this. I live in that world, so that's why I get excited about this stuff. But if I was doing a line of business app, I would never do that. So I hope that's helpful. If you have any questions or anything else you want me to look at, please feel free to send me a message or leave a comment. I love doing this, and we'll keep doing it because, you know what, I just get a kick out of doing it. So hope to hear from you soon. Goodbye.